Okay, so now that we know the rule, let's use it. In 6.3, what's really nice is we have rational expressions, as you can see here. Lots of situations where I have a polynomial divided by a polynomial, and we're adding and subtracting them. And the good news is we're already starting off with the same denominator. So that is nice. So again, as we just saw, if I have the same denominator, I keep that denominator, and I add, in this case, my numerators together. There's your addition rule. X plus 5x gives us 6x over 10. And probably the most difficult thing here is the idea is our final answer has to be in lowest terms. So we simplify our fractions. Again, just to be consistent, some of you can probably already see that 2's in common, but what we're doing right now is we're factoring both the top and factoring both the bottom. So I just want to kind of keep that rhythm going no matter what. So the 6x factors into 2 times 3x, 10 factors into 2 times 5. I see that common factor of 2 divides out, and so our final answer for that first addition is 3x over 5. So there's the good news. In the next one, we're adding again. My denominator is the same, so I keep that denominator and I take my numerators and I add them. Good practice to put things in parentheses, especially if there's more than one term. So we have x plus 3 minus x. So we can see what we're basically down to now, right, is how do we add polynomials. And when I'm adding, we can simply drop the parentheses and just add. So we have an x, take away x, that's 0, and so we're left with 3 up there. And that final answer is all we got, because this 3 down here is a term, right? Not to be confused with 3 up here, which is a factor. We only divide out common factors, not terms. So that was already in a nice simple form for us just by simply adding. So we're all done. Next one, we're still adding. My denominators are the same. So the idea is to keep the denominator and add up my numerators, right? And so we just have nice monomials here, which is why I'm not using any parentheses. So we have b plus 2 upstairs and b squared minus 4. We actually can't perform any simplification up in the numerator, so we can go into our simplification. B plus 2 is already factored. B squared minus 4, well, that's a classic example of our difference of squares. I can see a common factor of b plus 2, so there's a 1 left up in the numerator and a b minus 2 left in the denominator. So that's probably going to be our hardest part, is simplifying again, which is just factoring, find your common factor, and keep on moving forward. So there's our first 3 rounds of addition. We had the same denominator, I kept it, added up my numerator, and then simplified it where needed. So let's just keep on going. Getting a little harder. A lot more going on in number 4, but the good news is we have the same denominator. So I'm going to keep it, and then we're going to add one numerator to the other numerator. And since I've got a little bit more going on, I'm going to make use of those parentheses. As we see, we're adding polynomials. That comes down to combining like terms. So 3x and take away 2x, well, that's an x. And negative 5 plus a 3 would result in a minus 2. All over x squared minus 4x plus 4. So there's the addition. Now we have to simplify. So the top, well, that's already simple, right? And then the bottom, we can factor that. I believe that factors, I'm a guesser and a checker again. So let me check. First times first is first. Negative 2 times negative 2, last times last is last. Outer and the inner both give us negative 2x, which results in negative 4x. So I've got it factored. And so we see a common factor, right? An x minus 2 will divide out with an x minus 2. And this final answer is 1 divided by x minus 2. And so there we go. So again, we have the same denominator. We keep it, add up my numerators, simplify our final answer. Okay, and again, notice the difference between dividing out a common factor versus I didn't divide out common terms. We do not divide out common terms. We divide out common factors, break things up into products. All right, so let's switch gears. Those first 4 examples are addition. What happens when we subtract? Well, same idea. We have a same denominator, so I'm going to keep it, and I'm going to take my numerator and subtract my numerator. And again, how do we subtract? Well, it's the same thing as just combining like terms. So I have 4 minus 2x all over x plus 3. Looking to see if there's a common denominator, I factor, right? So the top has a factor of 2. I'll factor that out, and I don't see anything common, not even that idea of opposites, right? So this is an x plus 3. That's nowhere near 2 minus x. So we are simplified. Nothing more to do there. So there's subtraction. Same denominator. Keep it. Subtract numerators. Again, next example, we have x minus 2 is the same. So we'll keep it. And we'll take my numerator and I'll subtract my numerator. Again, it's a good habit to, when you don't have just one term, put it in parentheses, because look what happens here. Right? How do we subtract x plus 4? Well, we distribute that minus, which changes all the signs behind it. And so when we're left here, I think we have a negative x plus 1 all over an x minus 2. Again, everything is terms here. There's no common factors. So that's our final answer. We only divide out common factors, not terms. So there's a payoff of putting parentheses. Make sure that minus sign, we have to subtract the entire numerator. So change the signs behind it. That's how I show my work to make sure I capture it. But again, you see that rhythm. Because we have the same denominator, we keep it, subtract our numerators, simplify, and then we're good to go. So getting a little tougher, number 7, again, lots going on, but the good news is we have the same denominator. So I'm going to keep it, and I'm going to take one numerator, and I'm going to subtract the other numerator. So there's that work there. Of course, to subtract a polynomial, we change the signs behind it. Running out of room, so let me come up here. When I combine like terms here, 2x minus x is an x. And 3 minus 8 is a minus 5 all over x squared minus 25. So there's our subtraction. Now we need to simplify this result. And again, fight the urge. 5 and 25 do share a common factor, but they're terms right now because of the subtraction. So I actually have to factor. The bottom is a classic difference of squares. All right, and now I have a common factor, leaving us with the final answer of 1 over x plus 5. So again, common denominator, you keep it, subtract numerators, simplify, add your, combine your like terms up above, and then simplify by factoring out and finding common factors. Hopefully you're getting the rhythm. Number 8, we're subtracting. My denominator is the same, so I keep that denominator, and I take my numerator, and I subtract my numerator. And so to subtract, we change signs, combine like terms. Negative 3x minus 4x, well, that's a negative 4x. 5 minus 1 is a positive 4 all over x squared minus 2x plus 1. So there's the subtraction, excuse me. Now we need to simplify. And of course, to simplify, we're going to start factoring. Up above, I see a negative 4. And when I factor that out, what's left behind is an x minus 1. All right, remember, we always like that lead coefficient when we're done factoring to be positive. Down below, I'm a guesser and a checker. And I believe the bottom breaks up into x minus 1 times x minus 1. Again, checking it, x squared, right, plus 1, negative x, yep, it works. There's your common factor, it's x minus 1. So our final answer is negative 4, all divided by an x minus 1. And so there's your addition and subtraction of rational expressions with the same denominator. You keep it, add and subtract your numerators, combine like terms, and then you're back to what we did earlier in chapter 6, where we just factor the top, factor the bottom to divide out common factors and simplify. So there's your rhythm, there's your pattern. You guys keep on practicing.